Hey, what's up, guys? This is Steven with the MacSpace Mac Repair. We have a board that came across our desk. The board is basically a A2338 logic board. So let me go ahead and center this little, just kind of out, like, out of place here. But so what's going on here is that we have a dead board, no liquid spill, no damage, just failed. We kind of did a pre-test. Ian and I did a pre-test. Ian is also in the back here. We did a pre-test. We checked this area on the 12-volt fuse, and PP bus was not getting any voltage there. So they kind of gave me an idea that it's most likely a power line, a main power rail that's failed. So we're going to see if PP bus AON is actually completely shorted. We're going to go ahead and get started. Again, if you came across this video or you came across our website, we are the MacSpace Mac Repair. Thank you for watching. Hope you'll learn something over here and hang out with us. We are your local repair community. We're based in Marietta, Georgia, 2200 Roswell Road, Suite 130. We're a mom and pop shop. We're a small team. We're not large in what people think when they walk in the store. We are a normal Mac repair shop. This is what we specialize in. It's mostly Macs. We do work on iPhones. We do work on iPads. But a lot of the repair videos are mainly for Macs because these are more difficult repairs and it takes a lot more extensive knowledge to mess with. And we're not one of those run-of-the-mill mom and pop shops that just pops up. We've been doing this for quite some time, and we're growing thanks to you guys and those that are subscribing and those that have been hanging out with us and commenting in the videos. We do appreciate you. Also, for those that probably have watched one of my old videos, my son was born. The most recent video was probably many months ago, and my son is born. He is now over 6 weeks old. He is growing, and he is growing fast, and he's tall, just like his dad. So with that said, a lot of weight is on my shoulders. Got to run the shop. Got to run being a father. Got to be the boss. Got to run the shop, and then we developing some other things. Also, we have developed a brand new software that that's not really associated with the MacSpace, but it's like associated with helping a lot of software companies. So that's going to be on the lookout real soon. We can't really disclose too much about it, but you can kind of get an idea by going to the website how the website looks and how serious we are taking things. So anyways, let's get right into it. And also, I am a little tired. My head hurts, but I'm here anyways. I got to push through. That's just what Marines do. So let's go ahead and look at this. Let's bring the microscope over and see what we see on the board. All right, let's go ahead and fix our microscope. We're all zoomed in over here. And let's go ahead and adjust and take a look. I know some of you guys probably say like you could buy one of those filter cameras that filters really well automatically. Yours truly just hasn't had the time to get everything that, what Lewis Rossman or Northridge Fix or all the other guys have, and then they can use a program to do all that. But I'm just running the mill, just got to move. I got to keep moving forward. Eventually, when I get my time across to it, I'll fix it. These repair videos are just to help you show that we can do these repairs and try to diagnose it. All right, so go ahead and pull my multimeter out real quick. We're going to see if there's a short on the ground. Go ahead and pull the overhead real quick so you guys can see it. I'm going to pull this all apart. These things are sharp. Okay, we're just going to go ahead and probe the ground. Before we look, we're going to show you what we're looking at. So let's go ahead and show you what we're about to click. I gotta pull my keyboard out over here. So we got the A2338. Let's go and flip in the orientation the way it looks from my eyes so I don't get confused. And here we are right here, A2338. This is F5200. This is PP bus AON. We're gonna remove this, but first we're gonna just double check with it not removed to see if we get any shorts. Okay, we have a short, so it's saying here, let me see. Might be a false positive, I'm not 100% sure, but let me switch this overhead real quick. It says 0.8, and see if it drops down to 0 ohms, then there's definitely not a short and my multimeter is being stupid. No, it's staying at 0.4 ohms. Probably a very minor short here. No, it's dropping still. Oh, staying around 0.4 to 0.5. Okay, let's remove that. Let's remove that fuse, and let's see if that short is gone when I remove it on both ends there. And you know, we're gonna keep looking for it. We're not going in blind. We have an idea, because when you look at the board visually, I don't see any liquid damage. It just, the board magically died and it doesn't turn on, and it just stopped working. And we did actually, how do I say? I did actually plug up a multimeter to it, and the voltage reader, USB-C reader, and I only got like 5 volts. Ian got like 5 volts, and we were getting some weird amperage, and you know, DFU didn't seem kind of like a logical thing, but it didn't seem like it was a DFU issue or recovery issue. I may be wrong. We haven't gotten to that point. You know, I'm never always perfect. I'm human. But from my experience, looks like there's a short on the board. I just got to verify my assumptions here. So we're going to go ahead and take a look at this. We'll go ahead and pull my tweezers out and figure out what we got to do. I'm going to heat it up slowly. Gonna have to fix my eyes. Bear with me. Fix the eyes for you guys. There we go. Okay. And what I'm doing is I'm removing the 12-volt fuse, and I'm trying to isolate the short if there is one present. Now that it's showing that I only have 0.4 ohms, 0.3 to 0.4 to 0.5, it started off at 13 ohms, it went down, but it didn't hit 0, and it won't go down to 0, so something tells me that there's still a short there, because my Fluke multimeter is pretty accurate, but I wouldn't trust it if it hits like 0.1 and stays at 0.1. So heat it up a little bit, don't overheat. There we go, it's loosening up. Yeah, that's good enough. All right, we're gonna put it to the side here. And I'm going to check, I'm gonna check for the short now. Let's see what we got. Let's see if that short goes away. Pull the overhead real quick. Pull this bad boy right here. Let's see if we got a short still. Now those ohms kind of went there, but it's still dropping pretty quickly. Not as fast now. Still dropping. It's now staying at 0.8, so there's definitely a short present on the board. Let's check that line. No short present on this line. There is a short present on the line right there, but it's a very minor, it's not a very big short. So there is a short on the board that's preventing the computer from turning on. So what do we do here, you may ask? Well, since we know there's a short on the main PP bus AON rail, we need to inject a little bit of voltage in that line to find the short. And what we use right here is going to help us find that short, hopefully. I have a suspicion that it either is a speaker amp or something else. Since the short is present, I'm taking a wild guess here. It's not a wild guess based on repair experience. I'm leaning towards the speaker amp. Very common failure in these models. You know, there's no liquid damage. Usually speaker amp fails. Just sucks. It's random. Doesn't happen all the time, but it does happen. But if it's not that, I will, because here's one thing: injective voltages in that area may not turn that speaker amp hot enough. So I have to look really carefully at it with the this guy right here, so we can know what's going on. So we're gonna go ahead and inject voltage, but first, before we inject voltage, we have to solder the ground, basically, to the ground, the black cable to the ground. And then you have the red. So we're not soldering on this. This is just, we're injecting it with the needle one right here. So this one, I don't, because I need one hand to flip, one hand to flip and then one hand to inject. So it's soldered on and that's it. So we're gonna go ahead and solder that bad boy on real quick. I'm not gonna do it there because that's plastic. I don't wanna melt that. I'm trying to do an area that won't be so bad. That's plastic right there. Honestly, yeah, you can do it right there. That's fine. That's going to be grounded right there. This area right here will be grounded. My gravity of this thing is being bad. It keeps dragging itself. I don't know why. I'm going to do this real quick. Just going to go ahead and inject something right there. We're going to solder up some let it solder on that area because we want it to be able to connect with the other portion. Make sure this is grabbing. It's good enough for me. Don't need a lot, just need a little. That's good. Okay, now we're going to start off with 1 volt 5 amps injection. And keep in mind, guys, that if you inject more than, I would say, if you inject anything like 3 volts or higher, you're going to fry the CPU. You may not fry it at 3 volts, but you're definitely going to fry it if you go higher. 2 volts is kind of pushing it. I would always say 2.2 volts and lower is a little bit safe. You just push it, you're going to be making the CPU hotter. If the CPU starts getting hot when I'm injecting with 1 volt, then the CPU is probably fried already. But the reason why is that you don't want to inject voltage that high because it is going to fry your CPU. So if you're trying to do a board repair, you don't want to inject more than 1 volt. You can go up to 2 volts, but don't go any higher than that, in my opinion. If you're like doing 3.5 or higher, 5 volts, you're going to kill your CPU. So don't do it. All right. We're going to go ahead and do a quick overhead in a second. We're going to move this out of the way. Inject this voltage. All right, there is definitely a short present. I'm getting 1.4 amps on the power supply, which tells me there is actually a short on the board, which confirmed my suspicions. The question is where? And looking. And I found it. Found it right here. Right there. Big time. What is that? Is that the opposite side? Hold up. What is this area right here? It's a capacitor. It's a small cap. All right, we're going to go ahead and check that voltage one more time, and you're going to see it on the camera. Did you understand how I did that, Ian? So what I'm going to do, give me that alcohol thing, bottle, squeeze. I'm going to show you guys on the live video here. It's not really live, but it's a pre-recording, but it's not edited like what you think. All right, so the area that was getting hot, right there. You see that capacitor? Here, I'm going to zoom in right there. I'm going to zoom in real quick. I'm going to focus real quick. Okay, gotta fix the camera. Give me a second, guys. There we go. From the looks of it, All right, you see that? You see the alcohol cooking? Watch. You see that line on that capacitor right there? Let me zoom in for you. You see that line of that cap? Looks like it's cracked. That capacitor blew. You see the sizzling? See it's cooking? It's drying up that area. That cap's on the left. That little ceramic capacitor right there is it's done. What capacitor is that? Let's go ahead and look at the we know that cap is bad, but let's find out what that cap is. We're gonna go ahead and put the board view microscope. Now we know what that is. Let's find out what the cap is. No, you can speak. You can tell me. Ian's part of it. He's gonna be doing videos as well. He's like, he's trying to show me things. Ian can talk here. Here's Ian. Background. Yeah. Oh, he just walked away. Whatever. Got it. So this right here, this capacitor right here, this is what did I say? Wait a second. What did I tell you guys? It has to be something about the speaker amp, right? What's this area? Speaker amp. Usually the speaker amp goes bad, but instead the speaker amp didn't go bad, the capacitor did. So there's a probably likelihood that the capacitor is gone and maybe this right here is dead too. But I did kind of predict this in a way. It's like, I've come across where these boards are not liquid damaged, but they die. Well, either this or this capacitor has failed. Well, this capacitor decided to crack itself and die. Maybe too much music you playing too loud, by the way. That wouldn't be the cause, but possibly blast the music too much on your speakers and kills your board. So I don't know. Don't ask me. I didn't design it. It could be. Honestly, it could be a bad batch of capacitors, and it does happen when you have millions and millions and trillions of these. I don't know how many they make, but definitely that guy is bad. Now, with that said, we're gonna go ahead and replace that and see what it does. We're gonna go ahead and remove it. So let's switch over. All right, now that we know that there is a speaker connection right here, we have to cover up that area with Captain tape. It basically is it's like heat resistant tape, so you don't melt the plastic. Possibly we're probably gonna melt a little bit of it. You can't cover all of it perfectly, but just enough for us to. Will you do me a favor, Ian? Will you add in the parts hub universal parts for board repair to component parts, capacitors for A2338 and $1 capacitor. The capacitor is $1 because that's how much it costs to get it shipped to us, even though they're like 5 cents or a penny. But to get it shipped to you, it costs like $5. So better buy a whole bunch of them. Huh? Ceramic. It's ceramic capacitor. We're not gonna call it tantalum. Tantalums are the larger ones. Ceramic capacitor is those smaller ones. So just gonna say ceramic, C-E-R-A, ceramic, M-I-C, capacitor. And what is general term for them? $1. Doesn't matter the size. They're all pretty much the same price. Tantalums are not. They're a little bit more expensive, but they're still $1 because you had to buy them in batches where it's cheap. So we'll charge $1. Let me grab this out. I'm gonna go ahead and pull this. Got to cover this up. Sorry guys, I'm here. Don't worry. I'm just gonna do a few things here. There we go. All right, there we go. Now we're gonna go ahead and apply this guy. Also, with that said, we're gonna apply the heat direction going this. Oh, here, let me do it over it. Overhead, we're gonna have the heat going that way, not this way, because that's where the plastic is, and we don't want to burn myself and burn the plastic. We're not trying to melt it. That's why we have that Gafton tape up there for a reason, so we don't, melt the plastic where the actual speaker connects. So let's go ahead and grab my. Where's my thing at? I just had it. There it is. Go ahead and remove this. This down. Now you might be asking, like, don't you have one of those tweezers to pick it off? I do, but I'm a little like, I don't know. I like to do things just my way, what works for me. If it doesn't hinder your repair process, and you can get the repair done and get it working, I think it's a win anyway. Everyone has their own techniques. Find out what works for you without breaking the customer's data or breaking their board and all that. Now, if the board's already done, it's done. You really can't do much about that. It's a high-risk repair. But it's also very rewarding mentally and physically for people. It's supposed to be the unrepairable, and it's repaired. All right, bye-bye capacitor. All right, let's go ahead and do a, let's see. Let's go ahead and do a short test real quick now that we removed that. Overhead. This thing in a way. Short is gone. Short is gone. That capacitor was a short. All right. Dope. All right. Now that we remove that, we're going to transfer a new one. Well, I would say not new, but a donor. But, you know, it is what it is. We have donors, and that's all that matters. And yours truly carries donors every day. For this specific reason, we put this board over here. Here is a donor. And we're going to take it from the exact same spot because, you know, this one, it looks like it's flux over here. I don't really care about this one because this is a donor board. I'm going to go ahead and remove it anyways. Those capacitors are both the same anyways. They're across the board the same, so not a big deal. Now I'm going to show you why you want to cover it with captain tape. Is that what it's called? My brain's not working today. You see what's going on with the plastic? This is why you got to have that. I want to show you why we cover it. This is actually a good example. Oh, wait. There you go. See that? Melting. See, I see it. Y'all didn't see it. Now, you see it melting? This is why we cover it. This is why we point the direction of the heat the other way. This is a donor board. Don't really care about it. I mean, I do care about it. I use it for parts, but that's about it. All right. Don't touch that area. You can hold this area and put it in the back of the bag. All right, bring his thing back. Now you see why I did that. Go ahead and put this bad boy over here. Doing the best I can to make sure it doesn't heat that area, but it's going to heat it anyway. Okay, that's good. It holds it right there. We're going to add some flux because it doesn't give a flux. I'm doing the best I can to make sure it doesn't, it goes grabbing. There we go. It's on. All right, it's on. There we go. Nice. Nicely done. Let's go ahead and remove. Let's go ahead and put one more final check for sanity. See if that short is still there or not, even though it was removed with that capacitor. Just for sanity check. You know, sanity's sake, we want to make sure that it is gone. And we're going to check. No short present. Good. All right, we're going to do one more thing is add that 12-volt fuse back. You gotta have steady hands, and yours truly's hands is getting shaky because he hasn't slept lately. You could blame the baby for that one, but here I am still doing it. Whatever. I don't want to. I'm a little stiffler on how things look, so gotta flip this. Come on. And of course, there I am not recording it in front of you. You know what? I'm not fighting this. I'm gonna do it the way that's supposed to be done. I'm like realizing that I'm that tired I forgot that you have to do this. Not that I forgot, is that I just want to do it. Okay. Doesn't matter which side. I just like to keep the 12 visually where you see the 12. I'm a little bit like to make sure the 12 shows. Okay. Just add a little bit more flux. Call me crazy. Let it pull itself. There we go. Nicely in place. All right. All right, overhead. We're gonna let it cool down in a second. We're gonna go ahead and remove the grounding. There you go. That's done. Okay, that's done. That's done. Have a good. I feel confident this is going to turn on, but to find out, we're going to go ahead and plug it up. Do a little test. Got a little USB connector right here. Turn it this way, and I need a USB-C cable, and I should have my meter. I got a meter right here. Okay. All right, let's see what the meter shows. Let's move this over here real quick. Let's see what the meter shows. There we go, 20 volts. 20 volts. I don't know if y'all can see that. Let me bring it up close real quick. Close enough. 20 volts. You can see it 20. If it's blurry, whatever. Sorry. It says 20 volts though. So it's turning on now. Board repair seems successful and it's getting a good amount of amps there. So all we gotta do is put it back in its housing and see if it powers on. If it does, we have successfully repaired his board and he can be a happy customer. So we're gonna go ahead and put it in the housing real quick. So I'm gonna go ahead and verify my suspicions that it turns on, and then we'll clean the board up. Let's go ahead and move this over here. We're just gonna do it. We got the housing right here ready, so we're gonna go ahead and put it in and see what it does. We make sure all I'm trying to do is get a visual that the Apple logo turns on. I want to see his data show up, but in its grand scheme of things, if the Apple logo is turning on, the computer's turning on, it has a brain. Now, if it doesn't show the Apple logo and it turns on and shows me the Apple logo, there might be an issue. And then we had to probably call the customer and say, hey, yeah, so about that board we got. So, but, man. Those conversations we don't like to have with our customers because we don't like being the bearer of bad news. But the bad news is if it's already damaged, there's not much you can really do about it. You just kind of hoping that we can fix it. Not everything's repairable, I'll say that. A lot of things are. Not everything is. That is, depending on how bad it is. Well, honestly, trying to I'm not even going to plug up the speakers because I'm going to take this all out, but I like to plug in a few things. that it needs to have. One, you got to have the trackpad connected if you want the computer to work. You don't have the trackpad connected, computer will not probably turn on. It'll probably give you 5 volts in some cases. So it's best to have it connected when you want to do a test like this. Touch bar, all that, connect those. And obviously the USB-C. Everything else, not really necessary. Battery, yeah, I'm not going to do that. We're going to see if it turns on. Then we'll check the battery after that. We're just going to do a quick check here. Make sure that this does turn on. If it doesn't, I had to put the battery connected fully, but I'm not too worried about that just yet, because if I see Apple logo, that confirms that it works. Trackpad's clicking. That's a good sign. There you go. Apple logo is showing. All right, we're good to go. All right, we will. What was that? 30 minutes? About 30 minutes. Where's my main camera? There it is. It was about 30 minutes. For 30 minutes. Not too bad. So there you go. Very easy repair. I'm gonna be straight up honest. I took a prediction, which based off of repair experience, speaker amp area, very common area that fails, that causes computer to die for no reason. Speaker fails. It has the PP bus AON line connected to it. Once that line gets cut, the bridge collapses, power goes off, you have no power. I think that's, I wouldn't say it's a design flaw, because you do need a lot of power, I guess, to go to speaker amps. You know, I wouldn't say a lot, but power to supply those amps. Just like you got to have good power, you know, like if you think about a microphone has to have phantom power for it to work properly. You can hear the microphone without phantom power, but the phantom power gives it boost so you can pick up the signal better. I think that they're probably, you know, it's a flaw, not in the design, but a flaw in the capacitors probably, or the speaker amps possibly, or it could just be a bad batch. Not 100% sure, but I am 100% sure about that it is repairable. So that area, if the speaker amp fails, it is repairable. It just got to find out what the cause is. And a lot of these repairs are pretty generally walk in the park until you start coming across people that throw their computer in the pool, or they throw it out the car and it gets rained on, or their daughter or their kid spills a bunch of milk on it and it's drenched in milk when you open it. You know, those repairs are a little bit more different, but we do take those on. So hopefully you guys saw what we did, and thank you for watching. And if you haven't subscribed to our channels, TikTok, YouTube, you name it, also check out our website, www.themacspace.com. We do now accept mail-in repair. So if you want to start mailing in your device, we now have modules to do that. Give us a call, and we will send out a form for you to mail it out and how to mail out your device. If you have a logic board issue, stuff like that, or if you had sent it to a repair shop before, you know, they said it's not repairable and it's a logic board issue, give us a shot. However, if you sent it to a board repair shop and they deemed it non-repairable, you're more than welcome to send it to us, but there's a likelihood if they're a reputable board repair shop, if they exist, they're more than likely telling you the truth. So could be something they might have missed. And if you do send us a board that has been repaired before, chances are we might not be able to repair it if there's damage beyond what they've done, or so we wouldn't know. But if it hasn't been touched and you spilled liquid on it, or you haven't took it to somewhere and you took it to a board, like a repair shop, and they just like, you got to replace the board and they didn't tip the board repair, send it to us. Thanks for watching, guys.